I'm Sharon Mackless at IDG, here with episode 38 of Do More with R, 3 ways to join data, base R, tidyverse, and data.table. Here, by joining data, I mean combining 2 data frames by 1 or more common column, not just tacking on additional rows. For this example, I'm going to use one of my favorite data sets, flight delay times. If you want to follow along, head to the bit.ly link on screen, bit.ly/US flight delays, and download data with the columns flight date, reporting airline, origin, destination, and departure delay minutes. Also get the lookup table for reporting airline. You can get all the code and links to data downloads at my associated InfoWorld article at the URL on screen. Let's get to it. First, let me read in both files the base R way. Here in this code, I first unzip the flight delay file and then import the delay and code lookup files with read.csv. Let's take a peek at both data frames. I'd like to add a column to the flight delay data with the airline name. The base R way is with the merge function. The syntax for merge is first data frame, second data frame, and then optional arguments if you need them. It doesn't matter the order, but whichever one is first is considered X, and the second one is Y. If the columns you want to join by don't have the same names, you need to tell merge which columns you want to join by.X for the X data frame column name, and by.Y for the Y one. You can also tell merge whether you want all the rows, including ones without a match, or just rows that match. In this case, I'd like all the rows from the delay data. If there's no airline code in the lookup table, I still want the information. But I don't need rows from the lookup table that aren't in the delay data. There are some codes for old airlines that don't fly anymore in there. So, all.x equals true, but all.y equals false. Let me run that. Here's the code, column names, all x, all y. Let me run that. Take a look at the resulting data. You can see now that my joined data frame includes a column called description with the name of the airline based on the carrier code. And my new data frame has the same number of rows as my initial delay data frame, so I didn't miss anything, as you see here. Next, let's look at tidyverse dplyr joins. dplyr uses SQL database syntax for its join functions, so let's take a look at those. A left join means including everything on the left, what was the X data frame in merge, and all rows that match from the right or Y data frame. If the join columns have the same name, all you need is left join XY. If they don't have the same name, you need a by argument. Note the syntax here. It's a vector. Left data frame column name equals right data frame column name. Both names in quotation marks. So now let's run that in R. Load dplyr, load readr, and then I'll read in the 2 files with read_CSV. With read_CSV from dplyr, I don't need to unzip the zipped file first. Read_CSV creates a tibble, which is a type of data frame with some extra features. Let me run the left join now. And then let's take a glimpse at the result. This join dataset now has a new column name with the name of the airline. You may have noticed that this was way faster than base R. Also a reminder here that the order matters in a left join. First one, my tibble, is the one where I want all the rows, and this is the lookup. Now let's look at a super fast way to do this with the data.table package. Here I load data.table. Then I use data.table's fread function to import the zipped file. To read the zipped file, I use fread's capability to call shell commands directly. That's what this unzip-cq part is, unzipping the file. all in one command. fread creates a data table object. A data frame with extra functionality. There are at least two ways to do joins with data table. One is to use the exact same merge syntax as base R. It works the same, but a lot faster. So I'll do that here. Much faster than base R. If you want to use data.table syntax, you can first use the setKey function to set which columns you want to join on. Then the syntax is, as you see on the last line of code, your lookup table here, or what was the right data frame, the one where you don't want all the rows, only the matching ones, open bracket, table with the data, and close bracket. There's also another option, instead of setting keys, using the on argument within the brackets. I won't do that now since I already set keys. Finally, I'll demo a package for people who like dplyr syntax or are used to SQL database syntax but want the speedy data.table backend. That's possible with the new dtplyr 1.0 package. Install and load the dtplyr package the usual ways, install.packages if you need to, and then library to load it. To use dtplyr, you need to turn data frames or tibbles into special lazy data table objects. You do that with dtplyr's lazy_dt function. I do that in the first group of code here, piping the results of read CSV to the lazyDT function. And same for the lookup table. You can see I've got a special dtplyr step object as the result. Now I can join those two objects the usual dplyr way. What I get back is a special dtplyr step object as well. If I print it, let's let you see that a little better. You can see the data table code that created the object right here with call. That can be handy. I can also see the first few rows of data and, important, a message that I need to turn that object into a data frame, tibble, or data.table if I want to use the data in there, which I do. I can do that with as tibble. And there are my results. After running some rather crude benchmarking, the two data.table methods were fastest. dtplyr was almost as fast, dplyr took about twice as long, and base R was 15 or 20 times slower. Major caution here that performance depends on the structure and size of your data sets and can vary wildly depending on your task. But it's safe to say that base R usually isn't a great choice for anything but small data sets. To recap, here's code to merge two data frames by a common column where you want all rows of the first or left data set and only matching rows from the other one. This is the syntax for base R or data table. This is the syntax for dplyr using a left join. This is syntax for data.table. Remember, you can also use merge. And the other syntax that doesn't need a separate setKey statement. I don't use it, but this is what the on argument looks like. So what if you only want rows from both data sets where there's a match? That's an inner join. Merge syntax for base R or data.table is all.x and all.y, both being false. With dplyr, use an inner join. And data.table syntax can also be this in addition to merge. I've left out the setkey command since I already explained them in an earlier slide. If you want to see rows in left or X data set where there wasn't a match, that's an anti-join. It can be very useful to run that after a left or inner join to see what didn't match. Sometimes you expect no matches, but other times you don't. I'd probably use either anti-join from dplyr or DT bracket syntax from data.table for this if I was looking to see rows that didn't match. Next, if you want all rows from both data sets, regardless of whether or not there's a match, that's a full join. For that, I'd usually use either merge with all equals true or a dplyr full join. And you can see the syntax here in this slide. Finally, one question I also see, what about joining on two columns? So let me go through how to specify that. So again, reminder that you can download all the code in this PowerPoint at the associated article on InfoWorld. For merge on multiple columns, you create a conventional vector of X column names, each in quotation marks, and a conventional vector of Y column names, also each in quotation marks, for by.x and by.y. If the column names are the same in both datasets, you usually don't have to specify them, even if they're multiple. But I usually like to anyway to prevent unexpected things happening. dplyr syntax is slightly different. Here, zip code should match up with zip and so on. That's from another example in the related article. Data.table has a couple of ways to set multiple keys in a dataset. There's setKey to refer to column names unquoted, and setKeyV if you want the names quoted in a vector. There's also data.table's on argument. With all these syntaxes just oh so slightly different from each other, base R, dplyr, data.table, my advice would be you might want to pick one way and stick to it, or store the multiple ways all in an easy-to-access place. Once again, you can download my PowerPoint slides and code for this video at the URL on screen. So that's it for this episode. Thanks for watching. For more R tips, head to the Do More with R page at go.infoworld.com/morewithR, all lowercase except for the R. You can also find the Do More with R playlist on the YouTube IDG Tech Talk channel, where you can subscribe so you never miss an episode. Hope to see you next time.